So now let's take a look at our hypervisor integration overview. And what we're going to see is that with ACI, we have policy coordination. We've talked a lot about policy before with VM managers. And the reason we call it VMM or VM manager or VM management in ACI is that we're agnostic to the type of hypervisor or virtual machine host that's running the virtual machines. So whether it is VMware, whether it's Microsoft Hyper-V, whether it's Red Hat KVM, whether it's Citrix Zen Server, we really don't care. We're going to integrate with and to some degree provide information from and request information, or provide information to and request information from the hypervisor. So we have this kind of policy from the network that's coordinated with the hypervisor and their virtual machine software center. So for instance, Microsoft Hyper-V calls it System Center, VMware calls it vCenter. Okay? And from this, we'll be able to glean information such as the VMs, the virtual endpoints. We'll detect where they are and place policy with them and keep the policy consistent with both our physical infrastructure, our leafs, and then also our virtual infrastructure, the VMware DVS, or even possibly a Cisco AVS application virtual switch, which really takes the place of the VMware software. Still considered a DVS, and we'll talk more about that later. So the policy stays sticky with the VM, whether it vMotions from one ESXi host to another, doesn't matter. The policy stays consistent. So we can have multiple virtual machine managers, and that's typical on a single fabric. Probably a little bit close to 70% of the market has, or customers, enterprise customers have VMware running. As you get into the service provider market, they're typically running Red Hat KVM with OpenStack. But actually a lot of enterprise customers, due to price and now the capabilities being greatly enhanced in the last few years, are beginning to explore and some even migrate and move to Microsoft Hyper-V. Microsoft Hyper-V also supports Linux containers as a VM, I should probably mention now as well as vCenter or ESXi does. So each VMM is going to be associated with the APIC controller as its own VMM domain. So we call them VMM domains, even though what we'll be using in our first example will be vCenter and ESXi. We could have multiple vCenters for a single customer, multiple vCenters for multiple customers with multi-tenancy, and we could also just have multiple VMM domains for not only multiple vCenters, but also for Microsoft System Center or KVM or something like that. So we have the theoretical of 16 million virtual networks, of course. This is due to how many bits we have for VXLAN. Now, with a virtual machine manager, if it's running VLANs, and some virtual machine managers have the capability of running VXLAN south of the fabric, so kind of independent or on their own, if they're running VLANs, which is what we see 99% of the time when we go out and do installations, quite honestly, is we see they're still running VLAN-based or VLAN ID-based virtual machine domains. So whether, standard switch or existing distributed virtual switch. So of course, that means that we're going to have a limitation of, on any one distributed virtual switch, we're going to have a limitation of roughly 4,000 VLANs, okay? And of course, this is due to a few of them being reserved, but only 4096 total, with the 12 bits that we have for the VLAN ID in the .1Q header. So we can scale this by creating pockets of 4,000 based EPGs. And then we can map those either to separate VXLAN bridge domains or even to the same bridge domain. So in other words, here I might use VLAN 10 for an endpoint, colored, indicated by purple. And here in the second domain, I might use VLAN 10. Now maybe I want those to be separate bridge domains. So I'm reusing a VLAN ID and I'm creating it in a separate VMM domain, which would create a separate distributed virtual switch. but I mean for them to be in separate layer 2 domains, and that's no problem. Because as soon as we ingress that into the leaf switch, we strip off the VLAN ID, and it becomes a VXLAN header. And I can map VLAN 10 here to one VXLAN ID, and keep that consistent with any VLAN 10 that I see coming from VMM domain 1. And then I could have VLAN 10 coming from VMM domain 2 and map that into a different VXLAN ID or bridge domain in ACI, and keep that consistent across VMM domain 2 for VLAN 10, but again, keep it isolated and separate from these two domains. I also have the ability just as easily to link them together. So basically map VLAN 10 from VMM domain 1 to VXLAN, let's say 10010, and then the VLAN 10 from VMM domain 2, I could also map to VXLAN 10010, the same VXLAN bridge domain. I have that choice, I have that option. So ACI does give you a lot of flexibility. So endpoint groups can take different network identities across different VMM domains. So this is also useful because maybe, for instance, I have vCenter with ESXi on one side, and maybe I have vCenter on another side, but maybe I also have something else like a Microsoft Hyper-V. And so I could map these two. Now, I might not be able to do vMotion across. However, I would be able to put them in the same layer 2 domain. Now, taking a look at some recommended practices for VLAN networks, and I mentioned the fact that as we go through this slide deck and as we really go through these modules and presentations, we're going to be talking not only about, by the time you watch this, what is very possibly old news, but you may not only run across older installations in customers, and I mean older ACI installations of 1.03 or 1.04, but it is also possible that you might read documentation on Cisco's website, and especially if you just Google something and you're not necessarily looking up the latest version of ACI, 1.1 or even a newer version, but by the time you watch this, if you just Google something, it's very likely that you may come across an older version in the returned results, and it may say something that seems conflicting with what I'm telling you here. So I want to make sure that, again, I'm covering what was supported when ACI first came out at 1.0, as well as what's supported today. So when ACI first came out, 1.0, we couldn't have any overlapping of VLAN IDs at the top of rack switch. So meaning whether we had one leaf switch or whether our rack mount or blade servers were VPC port channeled to the ACI leafs, meaning that I had two leafs, right, that had a port channel down to, or a VPC down to a fabric interconnect or a rack mount. Whether it was a single top of rack switch or a VPC pair, in which case it would be or really unique to both switches, I couldn't have any VLAN overlap. So meaning if I had, let's say, vCenter 1, maybe for customer 1, and a separate vCenter over here, if I had, let's say, VLAN 10 that was defined on one, and I had VLAN 10 that was defined on another customer's vCenter, or even another vCenter within a single customer, but it was meant, maybe data center isolation, or sorry, data center consolidation. I've been involved with those where we have different subnets at different data centers, but we're actually using the same VLAN ID, and we're wanting to combine or consolidate those data centers into one. We need the subnets to stay different, but we'd like the VLAN IDs to stay the same so we don't have to go change them everywhere. It used to have to be that you had to keep those on separate top of rack switches. So I would define a range like VLAN, let's say 10 through 20, we'll just keep it simple. Or maybe let's say I'd create range 10 through 1000 on one vCenter, and on another VMM domain, vCenter or Microsoft, doesn't matter, I'd create range, let's say 1001 through 2000. Okay, different VLAN IDs, if they were on the same top of rack leaf switch. However, today, we do have the ability to use overlapping VLANs if that's something that you need. I don't see it used too often, but it is a very nice feature when a customer has this issue where they say, you know what, on ports 1 through 10, VLAN 10 means this bridge domain, and on ports 20 through 30, VLAN 10, the same ID, means a totally different layer 2 bridge domain. Different subnet. We don't want those to cause any conflict and interact, but we really only have enough, we only really have the need to plug in ports 1 through 10 here and maybe 11 through 20 or 20 through 30 or something like that. We don't have a need or I guess I should say we don't have enough nodes or servers that need to justify a separate top of rack switch. They're all in the same rack. A perfect example of this is using ACI for co-location at a service provider, and the customer has only rented half of a rack, okay? And so another customer's rented another half of a rack, and they're not going to talk to each other about what VLANs they're using, so we're not going to discuss all that. So they're going to use whatever VLANs they want, and we want each customer to be separate VLAN space. So we now have something called per port VLAN, and if we turn it on, we can basically say that, let's say ports 1 through 10, VLAN 1 through 1000 mean one thing, and they're mapped to one VXLAN bridge domain in their own tenant through their own EPGs, and ports, I just used the example earlier of 20 through 30 means something completely different. VLAN 1 through 1000, the same range is being used, but they're mapped to a different tenant, different EPGs, and they mean different VXLAN bridge domains. So that's very possible now. The configuration is actually done under Fabric access policies, and of course we'll go in and do some demonstrations of this when we get to the demonstration portion. This is done under interface policies and under L2 interface, and here we can define the default is global scope, meaning that a VLAN is relevant globally to the switch, not globally to the whole fabric. Okay? I can still have VLAN 10 on leaf 1 and VLAN 10 on leaf 8 means something totally different, even if I'm using a global scope, depending on how I apply my interface policies to my switch policies. So I have to be careful of that. But I also have the ability to create a port local scope, and then each port that I apply this interface policy to at my interface profile, that is going to, the VLAN ID is going to be separate. And really what's done in the background here is essentially this. So here's what's really happening in the switch is we have our switch, and we have, let's say, port 1/1, 1/2, 1/3, and let's say 1/4. It's only a 4-port leaf switch. It's a really small one. So traffic comes in to, let's say, VLAN, and it's flagged or marked with .1Q VLAN ID 10, and traffic comes in here, port 10. And so what happens is, as traffic, before it gets mapped in the northbound ASIC, before it gets mapped to its VXLAN and gets transmitted north to a spine switch to be routed over to another leaf, ultimately, or another VTEP, really, virtual tunnel endpoint, then there is a mapping done. So really what happens is VLAN 10 comes in because we do need kind of a unique VLAN database here. And this is unbeknownst to the customer or to the end point, the node, whether it's a hypervisor or a bare metal server, doesn't matter. In order to keep it unique in the switch and kind of the global table, we actually map it to another, and this is all done in the background, you don't have to worry about it, but we basically take 10 that's coming in, and let's say maybe we map this to 100. And 10 comes in over here, and we map it to 101. Now these VLANs are not in the same TCAM space, they're not in the same VLAN database as these, so it does not preclude you from using VLAN 100. These two VLANs are different. Okay? You don't even necessarily have to know this is happening in the background, but a lot of people ask, how do we do this? A lot of students ask, and so I like to kind of explain we're doing VLAN mapping in the background, and then VLAN 100 and VLAN 101 are unique. So if I have, let's say, VLAN 10 over here, and I also want it to map to the same bridge domain, it maps to VLAN 100. And so even if I don't necessarily, let's just get rid of that right there. Even if I don't necessarily need to send traffic out through the VXLAN, but rather it needs to just go local here and be bridged and sent down to another host, it can do so on the same bridge domain, VLAN 100. And it's even possible that this might be a different VLAN coming in. It might not even be 10. It might be, let's say, 50. So we have this ability, and this is done through VLAN mapping. So this is using the per port VLAN feature. So we see these created in we already created them in the interface policy under L2 interface, and then we create a policy group, and we apply our L2 interface policy, and then these two test port groups or test policy groups, they now have per port VLAN significance.